All right, so we're diving into something pretty mind-blowing today.
Okay, I'm ready.
Imagine, like, holding the entire universe.
Whoa.
Like, every galaxy, every star, like, every tiny bit of dark matter.
Okay, yeah.
All in the palm of your hand.
That's wild.
Well, scientists are getting pretty darn close.
Really?
With the largest universe simulation ever created.
Wow.
We're unpacking this super fascinating article from scitechdaily.com.
Oh, yeah, I saw that one.
It's called Frontier Supercomputer Unveils the Largest Universe Simulation Ever.
Catchy.
Just came out this week, and it's got some really cool stuff in it.
I bet.
So, like, what makes this simulation so special?
Yeah, good question.
How did they even build it? And what secrets of the universe might it unlock? Let's find out.
I'm all ears. So the key here is the detail. Like an unprecedented level of detail.
Okay.
Previous simulations could only handle the gravity part.
The gravity.
Yeah, of dark matter.
Right.
But this one models both dark matter and atomic matter.
Oh, wow.
So the stuff that makes up stars and planets and even us.
Okay, that's cool. But why is that such a big deal?
I
mean, I know dark matter is kind of a big mystery.
For sure.
But, like, how does simulating both types of matter actually help us learn more?
Well, think of it this way.
Okay.
Imagine trying to understand Earth's climate.
Okay.
But you only look at wind patterns.
Okay, got it.
You'd miss out on crucial stuff.
Yeah.
Like ocean currents or solar radiation.
Right.
It's kind of similar with the universe.
Makes sense.
To understand how it evolved.
Yeah.
We need to see how dark matter and atomic matter interact.
Over billions of years.
Exactly.
This simulation allows us to do that.
Bingo.
So it's like we had this blurry snapshot of the universe, and now it's coming into focus.
That's a good way to put it.
We can finally see the dance between these two fundamental parts of the cosmos.
Yeah.
But hold on.
What's up?
How do you even begin to simulate something as vast and complex as the universe?
Yeah, that's the challenge.
We're talking about billions of years of cosmic history.
It's a lot.
That's where this Frontier Supercomputer comes in.
Yeah.
It's housed at Argonne National Laboratory.
I've heard of that.
It's the fastest supercomputer in the world right now.
Wow.
Capable of performing an unbelievable number of calculations per second.
Like how many are we talking?
Quintillions.
Okay.
That's a one with 18 zeros after it.
Jeez.
But all that power is useless without the right software, right?
Absolutely.
So how did they actually program this thing to simulate the universe?
They use this special code. It's called HACC.
HACC.
It stands for Hardware Hybrid Accelerated Cosmology Code.
Okay.
This thing has been in development for over a decade.
Wow.
It's constantly being refined.
To handle all that data.
Yeah, and the calculations.
Right.
The latest version of HACC used in the simulation is 300 times faster than previous versions.
300 times faster.
Yeah.
That's insane.
You need that kind of speed when you're recreating billions of years.
Yeah.
It's not just about speed, though.
Oh, right.
The code also has to be really precise and accurate.
Yeah, to make sure the simulation reflects the actual universe.
Exactly.
Imagine trying to account for the pull of every single particle.
Ugh, don't even get me started.
From the smallest atom to the largest galaxy cluster.
My head hurts.
Okay, my brain is starting to hurt just thinking about it.
Yeah.
But all this effort, all this computing power.
Right.
What's the payoff?
That's the exciting part.
Okay, tell me.
This simulation is so detailed, so vast, that it can be compared to real telescope surveys.
Really?
We're not just talking about pretty pictures here.
Okay.
This is data we can use to test our theories.
About how the universe works.
Exactly.
So they're holding a mirror up to the universe. Comparing the simulation to the real thing.
And you know what?
What?
That mirror might reveal some surprises.
Oh, you mean like things we didn't expect?
Precisely.
Yeah.
It's like a powerful new lens.
To view the cosmos.
Yeah.
Now, you mentioned some pretty amazing visuals in the article.
Oh, yeah.
Could you paint us a picture? What does this simulated universe look like?
One image shows the evolution of this massive galaxy cluster.
Okay.
Over billions of years.
Oh.
You can see these clouds of hot gas.
How hot?
Heated to millions of degrees.
No way.
And inside, tiny star particles trace the formation and movement of galaxies.
Wow, so it's like watching the universe being born.
It really is.
That's amazing.
Yeah, we can zoom in even further.
Oh, yeah. You mentioned star particles tracing the formation of galaxies.
Right.
Can you talk more about that? How does the simulation show galaxies being created?
It's all about tracking the movements and interactions of all these particles.
Okay.
Imagine each particle representing a clump of matter.
Right.
Whether it's dark matter or the stuff that makes up stars and gas.
Gotcha.
The simulation calculates how these particles attract each other.
Through gravity.
Yeah.
Pulling together over billions of years to form galaxies.
That's right.
It's mind-blowing that we can simulate this now.
It really is.
It's like unlocking the secrets of galaxy formation.
Seeing this cosmic ballet.
Yeah, shaping the universe.
And what's even more remarkable,
What?
This is just the beginning.
Oh, really?
Just scratching the surface.
So this simulation is a stepping stone.
Yeah.
To even more ambitious projects.
Exactly.
Even more detailed models.
And complex.
Of the universe.
Yeah, right.
Wow. So this is just the start.
Just the beginning.
Imagine what we'll be able to simulate in the future.
As computing power gets even better.
Yeah. Perhaps we'll be able to simulate the formation of the first stars.
Wow.
The birth of black holes.
Crazy.
Even the very origins of the universe itself.
The possibilities are endless.
Yeah. And with each new simulation, we gain a deeper understanding of the cosmos.
Uncovering secrets that have been hidden for billions of years.
That's incredible.
It is pretty amazing.
Well, this has been an awesome start.
I agree.
We've covered a lot of ground. From the sheer size of the universe to the intricate details of galaxy formation.
Yeah.
And it's clear that we're living in a golden age of cosmological discovery.
Absolutely.
But let's bring it back down to Earth for a minute.
Okay.
Why should this simulation matter to our listeners?
That's an important question.
Why should they care about what's happening on these supercomputers?
I'm glad you asked that. Well, it's incredible to think about, isn't it?
What?
This level of detail, it lets us do more than just look at the big picture.
Okay.
We can actually zoom in on specific areas like our own Milky Way galaxy.
No way.
And study how it's changed over time.
Now that's what I'm talking about. It's like having a time machine for galaxies.
Yeah.
Can we actually see individual stars forming and dying?
We can't track every single star,
Okay.
but the simulation shows us the overall processes.
Oh, so like star formation and how stars interact with each other.
Yeah, and the dynamics of stellar populations within galaxies. By comparing these simulated galaxies to real ones,
Gotcha.
we can test our theories of how galaxies are born and how they evolve.
So it's like a giant cosmic laboratory.
Exactly.
Where we can run experiments and tweak different things to see how it affects the outcome.
We can adjust things like the initial distribution of matter.
Okay.
The properties of dark matter.
Interesting.
Even the laws of physics themselves.
Whoa, hold on.
Within the simulation.
Okay.
To see how it influences the formation and evolution of galaxies.
So we can explore a range of possibilities.
Exactly.
To understand what shaped the universe.
The universe we observe today.
This is really cool stuff.
Right.
I'm starting to get why scientists are so excited about this.
Yeah, it's not just a pretty picture.
Right.
It's a powerful tool.
To test our ideas and make new discoveries.
Exactly.
Speaking of the scientists, the article mentions a team led by Salman Habib.
Oh, yeah. At Argonne National Laboratory.
That's right.
They've been working on this for years.
Developing and refining the HACC code.
Pushing the limits of what's possible.
It sounds like a massive project.
It was.
Especially given the scale of the simulation.
Yeah.
Did they use multiple supercomputers to run it?
You're right. It was a collaborative effort.
Oh, wow.
They used Frontier.
Of course.
But also Perlmutter at Lawrence Berkeley National Laboratory.
Okay.
And Aurora also at Argonne.
So they split up the work.
By distributing the workload, they were able to get results faster.
This is really amazing. It's a testament to collaboration.
And the advancements we can make when people work together.
To solve these big scientific challenges.
For sure.
So with these powerful tools.
Yeah.
What mysteries are they hoping to unravel? Well, I'm guessing dark matter is still a big one.
Oh, absolutely.
It makes up most of the universe.
Right.
But we still don't know what it is.
That's the biggest mystery.
So this simulation helps us study dark matter.
In more detail than ever before.
And maybe get some clues about its nature.
We can see how it clumps together, how it interacts with regular matter.
And how it affects galaxy formation.
Exactly.
So by simulating the universe.
We might finally get closer to solving the mystery of dark matter.
That would be incredible.
It would be a huge breakthrough.
But there are other questions too, right?
Oh, yeah.
Like, how did the first stars and galaxies form?
That's a big one.
And what role do supermassive black holes play?
Another mystery.
And how has the large-scale structure of the universe evolved over time?
So many questions.
Okay, wait a minute.
What?
How can a simulation tell us about things that happened billions of years ago?
Well, we don't have any eyewitnesses from back then.
Right.
But that's where simulations come in.
Okay.
We can set the initial conditions.
Based on our current understanding.
Exactly.
And then let the simulation run.
to see how things evolve.
So we can rewind the clock.
And watch the universe unfold.
Wow.
It's like having a front row seat to the greatest show in the universe.
The formation and evolution of everything we see.
And by comparing the simulation to real observations, we can check our understanding.
And make our models better.
It's a powerful feedback loop.
Constantly refining our knowledge of the cosmos.
And with each new simulation,
things get even better.
With more powerful computers,
we'll keep unraveling the mysteries of the universe.
And understanding our place within it.
It's amazing how far we've come.
It is.
From ancient civilizations looking up at the stars.
Wondering about their place in the cosmos.
To now,
where we can simulate the entire universe on supercomputers.
That's been quite a journey.
A journey that's not over yet.
This simulation is just one milestone.
On a path of discovery that continues into the future.
And as our tools get even more sophisticated,
we can expect even more amazing discoveries.
About the universe and our place in it.
For sure.
It's amazing, isn't it?
Right?
Like we can hold a virtual universe in our hands.
It's pretty mind-blowing.
But what's really fascinating is how this simulation acts as a mirror.
Oh, I see what you mean.
Not just reflecting the universe itself.
Right.
But also the gaps in our own understanding.
Shows us what we don't know.
Exactly. By comparing the simulation to real observations.
Yeah.
We can find those areas where our theories fall short.
Where our models need work.
Like those discrepancies.
Yeah, there's anomalies.
The things that don't quite fit.
It's like the universe is giving us clues.
I like that.
Whispering secrets.
In this language of cosmic phenomena.
And the more detailed our simulations become,
the
more clues we gather.
Like adding pixels to a blurry picture.
Until it all comes into focus.
And this is just the beginning, right?
Ooh,
as supercomputers get even more powerful, we'll be able to create even more detailed simulations.
More realistic.
It's almost overwhelming to think about.
I know what you mean.
What we might be able to achieve in the future.
We're on the cusp of a new era.
Where we can simulate entire galaxies.
In incredible detail.
Study the formation of stars and planets.
Even peer into black holes.
It's like science fiction is becoming reality.
It really is.
Makes you wonder.
What?
If we can simulate the universe so precisely. Does that mean we can eventually understand everything about it?
That's the big question, isn't it?
Like, could we unlock the ultimate secrets of the cosmos?
That's a question that's been around for centuries.
I bet.
Philosophers and scientists have pondered this for ages.
The pursuit of knowledge never ends.
It's a continuous journey.
We may never fully grasp the infinite complexity of the universe.
But it's the quest itself that drives us.
It keeps us pushing the boundaries.
Of what we know.
It's not about reaching a final destination.
It's about the journey.
Our constant learning.
And this simulation. This incredible achievement.
It's a powerful testament to that spirit of exploration.
It really is.
So for our listeners, what's the takeaway from all of this?
Why should they care about scientists simulating the universe?
On a supercomputer.
It's a reminder that we live in an amazing time.
A time of scientific discovery.
Breakthroughs are happening all the time.
Expanding the boundaries of knowledge.
And this simulation. This ability to recreate the universe.
It's a game changer.
It's going to lead to new insights.
Breakthroughs in cosmology.
And maybe even reshape our understanding of humanity's place in the universe.
It's a reminder that the universe is full of wonders.
Mysteries waiting to be uncovered.
And who knows?
Maybe one day.
One of our listeners will make the next groundbreaking discovery.
Pushing the boundaries even further.
Until then, keep looking up at the stars.
And never stop asking questions.
This deep dive may be over.
But your journey of exploration
has just begun.